It is one of the most widely used metals in the world. Every single day, more than 100,000 tons of copper are produced. China alone consumes more than 14 million tons every year. And to obtain just one single ton of copper, almost 200 tons of rock have to be extracted. But have you ever wondered how copper is actually made? We visited one of the largest mines in the world to discover how one of the most valuable metals on the planet is obtained. Modern civilization could not function without it. This metal is present in almost every part of our daily lives. It is found in motors, heating systems, and the electrical cables that power our cities. Copper is one of the best conductors of heat and electricity. It has exceptional resistance to corrosion. It is highly flexible, malleable, and can be recycled indefinitely. Here's the strange thing about copper. You almost never see it, but you use it every second of the day. Its biggest use is electricity, and one of the clearest examples is the wiring inside your home. The moment you flip a light switch, copper wires hidden behind the walls carry electrical current from the power grid to that bulb. When you charge your phone, run your air conditioner, use your microwave, or turn on your TV, copper is doing the same job again and again. It is used because it carries electricity efficiently, bends easily into thin wires, and lasts for decades without breaking down. Copper is hidden, but without it, the modern home would go silent, dark, and completely disconnected. But where does copper come from? Copper is found in the Earth's crust, in the most superficial layer of the planet, especially in sedimentary rocks, and extracting it is a complex process that includes several stages. The first step is to identify areas with the potential to contain copper ore deposits. This requires geological studies, sample analysis, and prospecting techniques to find places where copper exists in concentrations that are economically viable. The Chuquicamata mine stretches across the Atacama Desert in northern Chile. Surrounded by an arid and extreme landscape, this gigantic excavation is one of the largest open-pit copper mines on the planet. Every year, more than 300,000 tons of copper are extracted from millions of tons of rock. But before reaching the valuable mineral, enormous layers of waste material have to be removed. In some areas, the deposit reaches depths of 100 meters, which makes it necessary to use colossal machinery and tons of explosives. To extract the rock that contains copper, a massive drilling machine is used. It makes around 130 holes, known as blast holes, each at least 16 meters deep. That is the equivalent of a 5-story building. Inside each blast hole, workers place a powerful mixture of ammonium nitrate and fuel, along with a certain amount of a high explosive called ANFO. Then the hole is filled with waste material. From a safe distance, an operator activates the charges, causing the explosions to detonate in sequence. Each detonation is so powerful that it could bring down an entire skyscraper. The time between one explosion and the next is approximately 2 milliseconds. This detonation pattern is designed to fracture as much copper-bearing rock as possible. Thanks to technology and carefully designed blast patterns, the explosive energy breaks the rock underground while minimizing the dispersion of material and dust. After the explosion, and once it is completely safe to enter the mine, the loading of the ore begins. Giant shovels lift the material with their enormous buckets and deposit it into massive mining trucks. 1 ton of ore is needed to obtain just 6 kilograms of copper. So to produce 1 ton of copper, almost 200 tons of ore have to be extracted. The excavators collect the rock by lifting between 55 and 88 tons in a single scoop. That rock contains less than 0.5% copper. The trucks are almost 7 meters tall and have a capacity of up to 400 tons, which means they could transport the equivalent weight of up to 300 cars. Because an open-pit mine is so enormous, its operation is managed from a control center. This center is located in a tower similar to those used in airports, from where operators can observe everything happening across the terrain. But how is a dark mineral rock transformed into one of the most widely used metals in the world? Freeing copper from the ore requires different techniques, depending on whether the mineral is an oxide or a sulfide. To process oxide ore, the rocks are stacked in special leaching areas. The material is placed around the edge of the mine to begin the leaching process. There, it is sprayed with a diluted solution of sulfuric acid. Over several weeks, this acid slowly filters through the rock, dissolving the copper. The solution, now loaded with copper ions, is collected in ponds and distributed toward the processing plant. In a special channel, the copper solution is combined with an organic reagent that floats on the surface. Then an acidic solution is added, increasing the concentration of copper and making it electrically conductive. The solution is transferred into a series of tanks containing thin copper plates called cathodes. An electric current is applied, and the copper ions begin to deposit onto the plates. In just 10 days, each plate reaches a thickness of 2.5 centimeters and a weight of around 125 kilograms. The purity reaches 99.99%, which is essential when copper is used to manufacture electrical products. Extracting copper from sulfide rock is a more complex process. It begins inside a gigantic drum known as a mill. Inside, steel balls crush the wet rocks into fragments. When the material leaves the mill, it passes over a perforated conveyor belt that separates the smaller pieces. Those fragments continue onto secondary mills, while the larger stones return to the mill for another round of grinding. Once the material has been pulverized, chemicals are added to coat the copper particles, and a foaming agent is mixed in. The mixture enters flotation tanks, where air bubbles carry the particles to the surface. This copper-rich foam is collected and filtered to obtain a concentrate with a purity of between 25 and 30%. The next step takes place in the smelting plant. The concentrate travels by train to enormous yards, where it is mixed in layers with silica sand, known as flux. This sand helps remove impurities during smelting. At extreme temperatures, the mixture turns into an incandescent liquid. The slag, made up of iron and other minerals, floats to the surface, while the copper sinks. At this point, the copper already reaches a purity of 60%. Then it moves into a second furnace, where the copper content rises to 98%. The molten residue is poured into a pit, creating a stream of glowing slag that flows like molten lava. As it cools, it solidifies and becomes part of the landscape. Meanwhile, a crane transports the liquid copper to another furnace, where the final purification takes place. The purity increases to 99.4%, and the molten copper is poured into molds, forming large rectangular slabs called anodes. These slabs are cooled with water sprayers until they solidify. A hydraulic cylinder pushes them out of the mold, and an automated system moves them to a rinsing station, where the remaining release agent is removed. After that, they are sent to a refinery hundreds of kilometers away. At the refinery, the maximum level of purity is achieved. The anodes are submerged in tanks filled with electrolyte and placed opposite thin metal sheets called cathodes. When an electric current is applied, the pure copper transfers from the anodes to the cathodes. The impurities fall to the bottom of the tank. The result is copper with a purity of 99.99%, suitable for manufacturing even the most demanding electrical cables. This refined copper is then placed into a vertical furnace. The copper melts and flows down to the bottom. From there, it is channeled into a mold that forms rectangular blocks about 6 meters long. The molten copper passes through an opening in the mold and is cooled with water, forming a continuous rectangular bar. A set of rollers significantly reduces its diameter. As it passes through these grooves, the bar is transformed into a copper rod about 7 millimeters thick. The rod exits the system, and the machine winds it into a spiral. The coils fall neatly onto a steel reel. Then another machine compresses the copper coil so it takes up less space during transport. This reel of pure copper will later be turned into conductive wire, ready to carry electricity all over the world. And that is how one of the most important metals on Earth is made. From a massive open pit mine in the middle of the desert, to explosions, crushing, chemical reactions, furnaces, refining tanks, molds, rollers and coils, copper goes through an incredible transformation before reaching our homes, our cities, and the technology we use every single day. Like this video if you enjoyed it and share it with someone who might find it interesting. And don't forget to subscribe to this channel and turn on notifications to keep learning. See you next time.
Thank you.